Thank you very much. Those are excellent. Dr. Fielding, I have a question because when you talk about about biomarkers, it reminds me, caloric restriction reminds me of the Okinawa. Mothers of Okinawans suggest that their children eat only 80% full. They have very active lifestyle, and their longevity has been shown then. And this is some of the things that come back to me and was wondering, is ethnicity play any role in those? When you talk about caloric restriction, does it really shift between, people thought genetic makeup has something to do with how people age and whether that is one of the factors. And for Dr. Barreto, I enjoy your talk. I was wondering about the life study and more likely you say something about long-term, early, instead of life course, instead of late life. How early? When is the point that people need to take a look at? And it seems to me that some of the things that has to do with the biomarkers will be very helpful. But people know when it's going to be too late if you can't do anything. And that has always been the question we have for intervention. And thanks for the last study. That's elegant, and I hope we get some more from that. Particularly, I was still wondering from primates to man, is there anything you would say may not be so applicable to us? Thank you.
So thank you for your comments. I'll just say very briefly, I don't think we know enough about differences by race and genetics and epigenetics about who will respond and who won't respond to these interventions. And obviously we look at mean differences in many of these clinical trials, and there's a variation around that mean difference. Some people are very responsive to interventions, some people are less responsive, and I think understanding what affects that variability could very much be dependent on genetics and epigenetics, I think, and probably other things that I'm not smart enough to even think of right now. But I think that, yes, I mean, we need to do a better job of enrolling more diverse populations in our clinical trials as well, and we're trying to do that, but it's challenging sometimes. I'll let the others comment.
Yeah, well, just to respond to your question, I mean, it's the shift from late life to life course. It's because we are no longer looking at very frail, dependent individuals in the end of life, and we are looking before. When is a very difficult question to respond, but of course, if you look at the biology of aging, you will look at people at perhaps 30 years or before. If you look at changes in physiology, let's say muscle function, you look at people in the 30s. But if you look at function, because they will have declines, but that will not affect function. The function will be affected after. So WHO suggests for intrinsic capacity to start monitoring in the second half of life, so middle age onwards. And of course, you will not find any changes in functions in 45, 50 years. Perhaps with some diseases this will happen, but just very specific to a few people. And the most important declines will come after the 60s. But to respond in a quick response, it would be in the middle of, in the half of the life onwards.
I'm good, thanks. So I do think we still have challenges with the non-human primates, of course. They're much smaller, they have different activity, their lifespans are different. And again, going back, I think, to your original question, they are still genetically different than us. We have problems with genetic diversity among humans who are, have the same more similar genetic makeup than these non-human primates. So we won't have direct translatability, but I do think as we move from rodents to these non-human primates, we're getting a little bit closer, and they do let us do a few more things than humans will allow us to study. So it's just another step towards understanding and translating.
Please.
Good morning, Biplab Nandi from ILSI, India. Very nice presentations, all the three. I must congratulate and enjoyed very much. I have only one observation with regard to Roger's presentation. You mentioned, if I have heard correctly, that there are a lot of comorbidities which is quite associated with all this. There you have mentioned hypertension. I was wondering, hypertension, diabetes, type 2, which are closely related at the same time. And do you have any studies in that regard? Which one is more predisposing than that of the other, or whether these are just correlated and goes, simultaneously? I am raising this because in India, as you know, the type 2 diabetes is very much on the higher side. So whether it has got any correlation with hypertension per se, or it is just independent of each other. Thank you.
Yeah, thank you. Excellent comment. And I won't say too much except to say that, one of the issues we have in aging is that aging is the strongest risk factor for many of these chronic conditions like type 2 diabetes, cancer, cardiovascular disease, Alzheimer's related diseases. So many times it's not just dealing with one of those in isolation, it's multiple comorbidities. Whether there's a specific biological relationship between hypertension and type 2 diabetes, I suspect there are many causal factors that are overlapping, but I can't really say much more than that, but I agree with you, and these are both tremendous problems in the world now, so. Please, yeah. Please.
Hi, thank you very much. Really, really interesting talks. I enjoyed all of them. I have a question for Philipe and also a question for Isabel, if I may. For Philipe, I wondered how much you took into account kind of stressful life events in your cohort, because we know from the work of people like Elissa Epel that if you are caring for elderly relatives, which many of us do in middle age, that can unravel your telomeres, and it's the equivalent of about 10 years of aging. So there will be, we talked about epigenetics and so on, but there will be other life factors that will also accelerate aging. And for me, psychological stress or those life experiences would be one of those.
Well, it's quite a good question. I mean, I totally agree that the life stressors are extremely important and determinant in the way we age. In this database, we don't have this information because this is really real-life implementation. So the practitioners in primary care don't have time to look at all these elements. It's, as all of you know, it's very quick consultations. But anyway, we have an older cohorts in which we will be able to respond this kind of question from a biological side, how the life stressors can interfere with the biology of aging. I say in terms of biological aging because to look at how the stressors influence the age in terms of function and disease, you need much more people. You need really big cohorts in epidemiology. And our study, ongoing studies, we have only 1,000 individuals, but that are very well characterized in terms of biology. Have a huge biobank with biofluids and tissues and cells to be able to look at this kind of proposal.
And it's nice that you can do that prospectively as well, because currently all the epidemiological stuff is kind of after the fact. So I'm really in favor of this kind of prospective, ecological, momentary assessment that enables us to show what's happening as it happens. My other question comes as a middle-aged female to Isabel. So, and it may be naive, but I assume that primates, female monkeys, go through menopause. And I wondered at what age that happens in their 30 or 40 years of life.
So please forgive me, I've talked with Julie about this, but I think it's around the age that we're looking at, so sort of in this middle age time period.
And we all know that estrogen is a wonderful appetite suppressant, and there's been an awful lot of research showing that, food intake varies across a menstrual cycle in normally cycling women, and it's one of those things that is attributed to the weight gain that occurs in, unfortunately, in most middle-aged women. And I wondered, therefore, whether that was related in some way to the lack of effect that you saw in your female samples, and whether that was something that had been examined.
So maybe, please let me rephrase. The females also had the weight loss during the diet. They just weren't able to maintain it. And whether or not kind of these sex hormones play a role in why we had maintained this is definitely something that we will be looking into. We hadn't measured it because technically all of that data we had post-diet, we said, okay, we're writing this paper up. Do we have any more information on sort of what happened? And we were very surprised to see that there was this dichotomy, but these monkeys had already been enrolled in sort of different studies. So then we were even more surprised that these males had maintained it. So we split them up into any sort of monkeys that would have had an intervention, and we removed those. But then we still saw that even though they were enrolled in slightly different things, they had maintained this. But we weren't able to take all of the measurements that we should had we originally planned to be doing this longitudinal analysis.
And we always find that men tend to eat for fuel and females eat for emotion. So, there are psychological factors in that too. So if you want to do an appetite study, we would always say do it in males. For exactly those reasons. Really fascinating. I think one of the things that opens up for us is to think about how nutritional interventions can actually help with that aging process. So we've done some work on things like hibiscus and shown that hibiscus has an impact on blood pressure, hypertension, that is indistinguishable from pharmaceutical intervention. So there are things in our nutrient intakes that we can then start to really apply in those situations. And I think that's something that's probably of great interest to the audience here as well. So fantastic food for thought. Thank you very much.
Yeah, I do think that the whole area of nutritional interventions that target specific or global hallmarks of aging is really sort of untapped, really. And I think, now that we have some ideas about how pharmacologic therapies affect many of these things like senescence and proteostasis and all these things, to think about natural products that can do this, nutritional compounds, I think will be really interesting.
Hi, I'm Jeff Smith from ILSI Southeast Asia region. Fantastic presentation, fantastic session. So I'll limit to a quick question to Dr. Beerman. Maybe I missed it, but I wonder if you could comment on the physical activity aspects of the primates. So was there less physical activity on a restricted diet? Was the average physical activity high? I don't think of these primates as necessarily sedentary. So how could you characterize the physical activity and, of course, the signaling that might send in any reduced ability for physical activity?
That's a really great question. And we didn't really, so all of this was based by their animal caretakers. So every day they are managed and sort of maintained by the animal caretakers. And this was a question we had for them, because if this diet led to any sort of changes in behavior, were they sitting in the corner more often? Were they less interested in their, they have like iPads, they have things that they play with in their cages. They said that they behaved exactly the same as their cohorts. There was no change in their physical activity, even though we didn't monitor them as closely as had they had accelerometers or something like that attached to them. It was mainly just observational by their handlers that said that there was no change in their physical activity.
Doug Tarrant, University of Colorado. I have two questions. One for Dr. Barreto. I want to make sure I heard this clearly, that you spoke about restriction in psychological health in these older populations. So I'm wondering about the GLP agonists that are restricting appetite. And I'm wondering if there's an age limit where maybe it's not helpful for the psychological reasons, because the older people would then have very much a reduced appetite. And I do remember reading an article in either NPR or New York Times about one of the side effects of GLP-1 agonists was during the holiday seasons when people don't have an appetite, and how does that affect their psychological profile? And then for Dr. Beerman, I'm also wondering, I think you had mentioned something like the microbiome affecting the metabolic outcomes. But I'm also wondering when those measurements were done, and is it actually, because the diets don't change, right? The dietary composition was the same throughout the study, right? They're getting the feed all the time. So I'm also wondering, is it really the opposite? Is there something going on with metabolism that's also affecting the microbiome at that point? And it's not really the microbiome driving the metabolism.
Well, if I can try to respond, I think you raise an important aspect. It can be one of the players in the appetite psychology association, but I think this association is much more complex than that because I have not shown that here, but it goes in both sense. I mean, appetite will influence mental health, but people who didn't have appetite loss at baseline, but developed appetite loss 6 months after, these individuals, in general, they had depressive symptoms in the beginning. So appetite will lead to depressive symptoms, but depressive symptoms will also lead to a decrease in the appetite. But it's interesting cue to follow. Thank you.
And in response to the question of which is affecting which, the metabolism affecting the microbiome affecting the metabolism, I think maybe we were nearsighted in how we thought of it because the microbiome changes persisted. So we thought that there was something going on specifically there when the metabolome essentially reset back to baseline. So we thought that it would be specific to the microbiome, but again, to me, I still don't quite understand why eating the same thing with just less amounts would have such a dramatic effect on the overall microbiome, unless, like you said, it's acting through metabolism that's then affecting the bacterial composition, and that's just more sustained.
And the other piece would be just that it may not be metabolism, it may be also lots of gut hormones that are in the lumen that's affecting the microbiome.
We've got time for one more question. I just do want to say the GLP-1 agonists will be approved for obesity in the future. And given the fact that the prevalence of overweight and obesity is very high in older adults, I don't think we know a lot about what's going to happen when older adults get treated with these agonists. Regardless, they lose weight, they lose lean mass, whether that's bad or good, we don't know. And the effects on appetite, I think, are yet to be determined in that group. And I think it's going to be a reality, I think, so we better learn a little bit more. One final question, thank you.
Yeah, thank you very much for your nice presentation, 3 of them. It was wonderful. I will bring a philosophical question maybe. What is healthy aging? Because we can think of healthy aging about free disease during a long period or control disease during the long period. They are 2 different things. Because, for example, having described that in elderly people, it's good to have them in overweight phase 1. This is protective against mortality compared with normal weight. I mean, and I would like to bring these questions to you, because this is related at the end with calorie restriction, with senescence, how we match this kind of things in the elderly life.
Thank you for your comments. Yeah, I mean, I think we acknowledge that aging is the strongest risk factor for many chronic diseases of old age. I think how aging and disease burden interacts and how we intervene is still, something we're learning about. I don't know how to answer your question. Do you have any comments,
Maybe just
Isabel?
a comment to that is, I think the term here is intervention also, right? We're trying to prevent some of these aging phenotypes. The challenge is when you already have the aging phenotypes, are we able to ever sort of revert them back to something healthier? So, following your talk, it's almost saying we studied middle-aged monkeys for a reason, or middle-aged mice for a reason. When we try to put our rodent models, our aged rodents on caloric restriction, it's terrible for them. They can't sustain it. It's not even a social thing for them. Their bodies just can't tolerate that. So it's not a positive benefit when they're at the geriatric period. So these are interventions that are sort of staving off these aging phenotypes. We also have to consider, are there things that we can do once we've passed this period of intervention and sort of we're thinking about, I guess maybe reprogramming might be the term we're looking for, or rejuvenating. And those are slightly different questions, I believe.
I think we should end it there. We're on to our coffee break now. I want to thank the organizers again and really thank my colleagues and excellent speakers for this panel this morning. Thank you all very much.